So this week we'll start with a small story or small update on the EUDR. Because I think there's a major update like a couple of weeks out. I think I read somewhere.
The benchmarking system, yeah.
Yeah, exactly. And so this story is, and it's not official, but someone heard or learned this, and it's a story from Erective, I think it's called, right? And actually, you were the one that found it.
Yeah, I don't know that site, but I think that's what it's called, yeah.
Yeah. So apparently, EU are to label 4 countries as high risk, and it's Belarus, North Korea, Myanmar, and can you guess the last one? Rasmus, you haven't read the story. Who could it be?
It could be
China.
China? No.
Close.
I don't know.
Russia.
Okay, yeah, but you're mentioning dictatorships at least, almost. I don't know if Belarus is. But
Yeah, Belarus, North Korea, Myanmar, and Russia. And for some reason, and maybe I think that's the sort of underlying theme in the story is that maybe some lobbying efforts has made sure that Brazil and Indonesia are not on the list.
Yeah, I'm a bit surprised.
Yeah,
to be honest, but I think it's something to do with they already.
Sanctions.
Yeah, exactly.
Yep. Go ahead.
No, that was all pretty much.
Yeah.
I don't know much about
It seems like that's the sort of that's the thing they've used to decide on who was high risk and who's not high risk. So it's high risk, it's standard and low risk, right? That's the 3 levels. Yeah. And of course, a lot of NGOs are also a bit critical and skeptical to why we only have these 4 countries labeled as high risk. The official list is supposed to be published in June, so in due to short time horizon.
Yeah.
I think that's it. Do you have anything to add?
No, I mean I look forward to seeing that list.
Yeah.
I mean maybe we already know it now, but that's one of the things that cause a lot of confusion, I think.
Yeah.
How much work do we need to put in if we don't know if we're a low risk country yet, or where we're sourcing our products or commodities from, what risk they are. So we don't really, because it depends what you need to do.
Exactly.
The risk. So yeah.
Maybe
some clarity will come.
Yeah, I think that would be welcomed. Yeah. Okay, moving on. Before we get to let's say the big stories, also have a small update on the space trolley. Yeah,
it's friend of the house.
Yeah,
now.
3 weeks in a row.
Yeah,
it's about to trump.
Oh yeah,
Ding.
yeah, probably.
Nah. Okay, so of course I don't know if you remember, but it's called the Biomass Project. That's sort of the label of it, the project. So ESA has released its biggest forest biomass dataset ever. And this dataset covers measurements from 2007 all the way up to 22. And it's a global map with measurements on above ground forest carbon. So and the thing is, of course, the idea with this is to have the knowledge in terms of climate models, forest management, and UN reporting. And it's a combination of data coming from JEDI, Sentinel-1, ICESat, and ALOS Pulsar. And I'm no satellite expert, so there's a lot of names here. I don't really know what that is. Oh. But if we are to talk about this every week, then I think at some point in time we will be satellites experts. So the updates in this new dataset they've just released is they have fixed some old underestimates in dense forest. Apparently, when you get above 400 tons per hectare in biomass, it gets difficult because it gets too dense. And that's, of course, one of the major sort of new things with this space brolly, which has this B-band radar. It'll be able to, penetrate the canopy and then have a better measurement on these very dense forests. So that's the next sort of step in terms of enriching this data set. But it's actually quite funny. If you go to the ESA page and find this biomass project, there's actually a lot of news concerning this project. So it's definitely something that I at least will have a close eye on what's happening. I think it's really interesting. And I can see Rasmus is about to explode of excitement. Right?
Yeah, but I'll
send you the data set in an email. Now we can actually go download it.
Yeah, it's probably large and needs some.
It probably is
some work.
Yeah, and I think now I haven't added this to my notes, but I think the density. What was it? 100 meters to. Let's see if I can find it.
The density.
Yep.
Pixel size or.
Yep. So it's not what's called fine masked. No, I can't remember it, but it varies the density of it, the data. So it's not something that we can use.
No, it seems like you said it was 100 times 100 meters, maybe somewhere.
Yeah, and above.
Yeah, that's pretty. But it still gives you some indicators if it's growing off or.
Yeah, and in terms of the applications and use case, of course, forest management is also part of our use case. It's probably okay, but not in terms of the forest management that our program is capable of doing. But it's interesting.
You get some kind of baseline to see if what you're doing is fair.
Yep.
But if you change the way you measure, then you can't historically compare.
Yeah.
It's at least hard because the new one will give a better estimate.
Yeah.
But you can, of course, then
you
go back and say
data fusion or whatever it's called.
Yeah, correct your previous data or something like that.
Yeah.
Yeah.
Good. And then one more thing before we get to the actual story. And this one is for you, Rasmus.
Yeah, hit me.
I'll put it like this. Leo will follow Francis. We are going forward with environmental protection.
Leo.
So the Pope is still behind the environment.
Oh, okay.
Pope Leo.
I thought it was Leonardo DiCaprio.
Yeah, it could. He would also say that.
Yeah, exactly.
Yeah. So there's
good.
hope. There's hope, Rasmus.
The hopes and prayers are with the environment. Hopes and prayers.
Yeah. Yeah. What is it that you say that beliefs can move mountains or something like that?
Yeah, that's right. I think that's pretty accurate.
Yeah. Okay. Let me just take a sip of my coffee while you just.
I'm praying.
Yeah, while you're praying. Okay, story one. Interesting story. And the title is Super Wood Stronger Than Steel, Ready for Production. Okay?
Mm-hmm.
So big news in forest-based materials. A new type of superwood that's stronger than steel is just weeks away from full production. It's developed by a company called Endangered Wood. This new material could be a game changer for replacing tropical hardwoods like ipe and walnut without cutting down endangered forest. So here are some key facts about this new superwood. You ready?
Mm-hmm.
Good. So it's actually 12 times stronger and 10 times tougher than natural wood.
Natural.
Yeah.
So it's not natural wood.
No. Well, I'll get to that.
Mm.
And Rasmus, we always look for, 10 times better. That's where it gets interesting.
Yeah.
Because then it's significantly better.
Yeah. It's not just incrementally better.
Yeah. So when I read this, I was like, okay, you got my attention. So it starts from regular timber strengthened by pressing wood fibers together.
Mm.
Mm. And now we're looking at you, Benjamin, because you're by far the most woody expert of us. So it's your turf, this one.
Okay.
Yeah. Okay. So the process densifies wood 4 times by increases strength over 10 times by creating new hydrogen bonds. So imagine, you're going deep down into the wood, and then you should see the structures now, right?
Yeah.
So it's developed from research at the University of Maryland by material scientist Liangbing Hu. Do you know that university? Is that like a famous wood university?
Maybe it is. I'm not. Yeah.
Okay. So the factory was built with a $12 billion funding from some climate-focused investors, and the first products will be for skin applications.
Skin applications.
Yeah, I was. What the hell is that? Skin applications is apparently what you call something that goes on facades and panels.
Yeah, so not for structural.
Yeah, but the goal is to replace concrete and steel in building structures. But skin applications first.
Like all the other woods.
Yeah.
At least how we have used it for.
Yeah, but you have like glue lamp,
yeah.
and stuff like that for the structural part of. Yeah.
But maybe just to understand, you do not. This is not like the same where you glue stuff together. You do something with the wood, pressure it, compress it, turn it into diamonds. Well, that is what is done over millions of years.
Yes, you can say that. Okay, some extra benefit. It's Class A fire rated. It's resistant to rot, pest, and fire. Can mimic the natural colors of tropical hardwoods without staining. And the goal is to turn low value wood chips into beautiful structural beams.
Okay, so wood chips you.
Yeah, so that's how you compress it.
Yeah, okay.
So shitty, logs or, right? Chip it up.
Yeah, we use that for something else in Denmark, but maybe in the future we're not allowed to.
Yeah. Okay, so Benjamin, what's your opinion on engineered wood as a in general, as a thing? Are you a fan?
Yes, of course.
Yeah.
Everything wood-based that replaces, steel and concrete. I'm a fan.
Yeah.
And there's a lot of talk about what role will wood play in the future. And some people think that you only need to produce fibers. It doesn't really matter. What density or whatever, if it's can be used for construction. You just need to produce volume.
Yeah.
And this speaks to that.
Yeah, exactly.
Saying. So yeah, maybe that's the way forward.
Yeah. At least I hope we get to that. I think that makes sense.
Yeah, and that's basically how it is now. The slow growing conifers have higher density, so they're stronger.
Mm-hmm.
So it makes sense, to increase density if you can do that in some way. Yeah.
When you talk about, the wood chips coming from, either this species or another species, the properties of let's say, the wood when it's in its sort of natural form and shape, does that? I assume that also reflects all the way down to just the chip, right?
Mm.
So. If you take like a portion of something where the strength is very good, based on a normal sort of timber or log, and then for chips, that will also sort of transform its way into engineered wood like this.
Yeah, I would assume so. Yeah.
Yeah.
In Denmark we have this product called. Yeah, it's basically for panels in the ceiling to, how do you say that? Sound.
Trolltex.
Yeah, exactly. And the wood used for that is Norway spruce, 50 years old.
Yeah.
There's one for 40 years old, the second class of it, I think. but that has something to do with the density.
Yeah,
I've heard somewhere some clever guy said that it's something to do with the density. So and they completely peel the wood apart to these small strips and glue them together, and the density is still there. So it must mean something in that regard.
Yeah. So Rasmus, what impact do you think these engineered wood will have on the building industry?
Yeah, I guess first of all, it's so. I guess we started with just burning the chips because that was probably also other places because that was it's a good source of energy. Something to burn, and then we also use it to scatter around gardens to keep or make them look nice. But this is just another level of how you could use it. But it makes perfect sense that you look into the good solid timber. You can use that for construction, like nice floors and so on.
Mm-hmm.
And then you have this product that is there when you produce wood, so why not see if we can use that in a better and better and better way? And this is just another evolutionary step on using that better.
Yeah.
I assume that one of the issues with it now is that it's probably expensive to produce, and that's why it could probably be stronger than steel, but steel is probably cheaper to produce. So, but that's also this is the start of that evolution. So it probably fall in price, and it's nice that we have this product that typically we would burn it because we don't know what else to use it for.
Yeah.
But if you can create a market where it has much more value in another sense, that helps, and it actually goes into construction. Now you have also bound the CO2 for years. And that's one of the things that would be nice to do if we see the forest and the wood as something that takes in CO2 and capture it, that we also don't release it right away.
That's actually interesting because since you sort of compress this, and make it more dense than normal, let's say wood, you will actually increase the level of.
I would assume it's the water and everything else that you get out of it, and you only have the clear carbon. There almost, and that's what you use. Yeah. So it will also be storing more carbon.
Yeah. So one more upside.
The question is, how much carbon does it cost to produce it then? I don't. That's under pressure, you need.
I also wonder if sometimes we in Denmark when there's a dead tree, you would chip it.
Yeah.
I don't know how the fibers or the density or how the the wood properties of our of dead trees and
that's a good question.
Yeah.
So I'll just show you this. And also you, Rasmus. So this is what it looks like.
It looks much like a normal, what's it called?
A plank or
Yeah. So one of the things that's also mentioned here in this article is, of course, that this is actually a nice looking plank, and maybe you could use this as a replacement for places where you normally use hardwoods, terrains and stuff like that. Do you think there is a use case for materials like this replacing, the real thing?
I mean, one of the problems is if you need it outside, for the species we get from the rainforest is often because of their preserving or the longevity of them.
Yeah,
I don't know how this.
I think this is very good on this.
Okay.
Engineered wood.
One of the things that you do to make the wood really good is that you try to eliminate all the water out of it, right?
Yeah.
That's how I remember it. We visited some of these places where they dry the oak for years almost, and they use vacuum tubes to pull out the water from them.
Yeah.
And my guess is that if you compress it like this, the water must be removed.
So invent wood, then treats it with food industry chemicals to modify the wood's molecule structure. The wood is then compressed to increase the hydrogen bonds between the cellulose molecules. We might densify the material by 4, and then you might think, oh well, it'll be 4 times stronger, but it's actually more than 10 times stronger because of all the extra bonds that get created. Yeah, so the result is building materials that had at least 50% more tensile strength and a strength to weight ratio 10 times better than steel. It also class A fire rated and resistance to fire, rot and pest. And with the help of polymer impregnation, it can be used in outdoor applications like decking and roofing, and compressing the fibers also concentrates the colors, so you end up with something that looks a lot like those richer tropical hardwoods.
So they shoot chemicals into them.
Yep.
Yeah. And I think that's also one of the things that is not going to be there forever.
It depends on if we can make like a bio-friendly chemical.
I mean, this came from the food processing industry, the chemicals, so therefore they are somewhat safe.
Yeah, maybe you could argue that.
I mean, there is also wood that is, how do you say that, dried in an oven, pretty much. You know, like the Vikings, they put their ships and stuff into the fire to, you know, also increase longevity. There's also something like that in Denmark. Yeah, there is in other countries, which does the same. Maybe not as good, but pretty much the same as shooting chemicals into it.
Yeah. So, Rasmus, how will this new wood material, this has special properties. So how do you think that will change the way that we design and use timber in constructions? Because, that's also what we talked about with Maximilian, the defects of, that's why you do veneer and glue it together in new ways in order to make it more homogeneous. What's the name word I'm looking for?
Homogeneous.
Yeah, right.
Yeah. But this seems like that's the essence of it, that you break it down to the fibers.
Yeah, this is next level.
Yeah. Yeah, well, you don't glue anything together. You make it like I guess it's like a soup almost, and then you compress it from that.
Make a completely new plank or whatever it is.
And that's the next level. Yeah. In the other processes, you glue things together, but here you actually you mash them together to get these bindings, which is that's what makes it stronger, as far as you read up there. Mm-hmm. And that's so you don't need the glue to make that. You actually do that together, and that it seems like this is as you say, like the next level. And it also seems like, coming back to that talk with Maximilian, that this is actually something that you could use for race cars and these.
I wonder if you could do like special constructions where it's just a mold that actually defines what it is that you get.
That's the next thing. Yeah, if you can actually mold it into anything.
Yeah,
because of this way of doing it, that would seem like, why not?
Yeah, maybe we should have Maximilian come back and
and comment on this approach.
I would also be interested to know how much. I would assume you start with a lot and then compress it down to how much it takes to,
how much how
the
is
volume
that
reduction.
Exactly.
If
that's that one plank is like a full oak,
10 cubic meters.
But we don't know. But
good
and
question.
that's of course interesting because maybe you get a 10 times weight to strength ratio, but if you also get a reduction in coverage of the wood. If you do the terrace thing and so on, now you need much more wood to do that.
Yeah.
And what have you then achieved?
Yeah, it's actually 10 times more expensive than just a plank of wood.
Yeah, exactly. But both the price and also now you need to cut down 10 more trees.
Yeah, but then again, chips versus, let's say, a hardwood walnut. There's a difference in
very big price difference.
Yeah, and that's also probably one of the most positive things. If you just use the chips for this, why not? Why burn them if you can use them for something else? That actually is better than, or in some, I should say, there's some capabilities that are better than regular wood, then why not?
Yeah.
And it also makes a lot of sense because we always talk about selecting tree species that suit the climate the next 50 years, and some species are not approved for construction. Yeah, like a grand fir in Denmark, for example. Yeah, and I know a lot of people are working to approve it for construction because it has an insane growth in Denmark, and all that doesn't matter if you use it for this. You just need to produce volume. So grand fir is perfect for that. Yeah, you're right. 50 cubic meters a year.
Do you think if this, let's say, forget about normal use cases of timber, now it's just chips. We're only interested in chips from now on. What would that actually do with the way that we sort of managed or do forestry today? Would the forest stands rotation be shorter, or how do you see that, Benjamin?
I don't think so, because
you still want the time where it produces the most mass, right?
Yes. Yeah, and if you cut it down before that, you will miss a lot. So I don't think. I mean, you wouldn't care about nuts and stuff like that. So you could give them a lot of space. Yeah. And to just grow in diameter. Yeah. The overall quality, it doesn't matter if it's straight. All of those things we care a lot about now. Yeah. So you could maybe plant a lot less to begin with.
Yeah. Would that benefit something like biodiversity? Would it be more, let's say, not dense, but
probably, yeah. They would grow together eventually, but in the beginning there would be a lot more space, and it would be a lot cheaper. So a lot of benefits in many ways. Yeah.
Okay. Maybe you can look at a little as you have the steel industry or the plastic industry. There you just take the iron ore, and then you create something. Yeah. You don't have to. And this is kind of the same. We just want the.
We just want the material.
Yeah, we just want the resource, the natural resource. Yeah. Don't really care much about what it looks like. Yeah. And then we manipulate it into something. Yeah. And you can optimize for something else than good wood, as you also said. Yeah. And now you can just look at the growth curves, and if the gradient of them begins to drop, cut them down. Yeah. Plant new.
Cut them down. Yeah.
But that would be maximizing CO2.
Yeah. Yeah, that's the thing uptake. Also. When you talk about biodiversity, you would probably not plant the native broadleaf species because they grow too slow. Yeah. I mean, if oak, let's say 7 or 8 cubic meters a year, versus grand fir, on the good side 50 cubic meters a year. Yeah. Yeah, I wouldn't.
That's you have a point. The economical, incentives now. Yeah. We can do something about the CO2 now, but the biodiversity, at least, how many species do we actually have?
Exciting though.
Yeah, let's take a hot take on this one. Who wants to go first?
Okay, I can go first, but I would like to ask a question.
Yeah.
Do you think in our lifetime that we would be driving a wooden car?
A wooden car?
Yeah, where the material instead of steel and plastic and carbon, or I don't even know what they use in modern cars. Probably mostly just steel and plastic.
Aluminum.
Yeah. Mm-hmm. Do you think we will, in our lifetime, be where some of those are actually made from like stuff like this?
I think, to some extent. I think, as I recall, I think Volvo and Polestar, they do a lot of, sort of mixed composite materials in the inside of the car.
Yeah.
I know what you're talking about. I have no idea, but I think there is an openness to exploring a lot of, especially bio-friendly sort of materials in a lot of use cases.
Yeah, but the thing is, if you 10 years ago said, "Will we all be driving an electrical car?" we will also say probably not.
Mm-hmm.
Because
maybe.
maybe. I don't know. Maybe it's. Maybe
I think it
15
needs to
years.
go. Yeah, maybe a bit longer back.
And my former professor, he said that this is probably 5 years ago. So he said the generation born now will be the last one who needs a driver's license.
Yeah.
And but we don't know. This is just like the same. What's your prediction?
Yeah.
You have to say it. Will you be driving one of these?
If I will be driving, so is it a question about driving in general?
No, yeah. If in our lifetime, this is going to be. You'll buy a car from. You'll probably buy an Xpeng or something.
No,
this is an Xpeng
damn
guy.
not.
You'll be buying the first European produced wooden car.
Yeah, but I don't think that question makes sense.
Why not?
Because when you say like a wooden car, I think of Flintstones.
like a square wheel.
Yeah, I don't think that would be a thing. No.
Okay, do you think let's say the Tour de France, the bikes will be wooden?
No, but I think, but
too heavy.
Yeah, we have talked.
But this is something new now. This is much better.
Yeah, but I think a lot of applications will go, let's say, more nature friendly. Try to introduce, bio-friendly materials.
Yeah, it is kind of the next step. Now we have the electrical cars.
Yeah.
What's the next bio-friendly thing you can do?
Yeah, for sure. For sure. Yes. But I don't see myself, driving around in a Flintstone car. So that would be
an autonomous Flintstone car.
Yeah, that would be a no.
Okay.
Okay. Yeah, so for me, I'm a huge fan, and this is something that we have actually discussed, throughout the years. Where are all those new innovations and substitutes where it's just, fibers that replaces something? I can't believe that that's not a huge industry. And this is where we need to get to.
Yeah.
In my point of view. Benjamin.
I'm a huge fan as well. But like I also said before, I think it will also maybe shape the forests around the world.
Yeah.
A lot of the high producing species in monocultures.
Yeah.
We don't have monocultures, Benjamin.
No, we have none in Denmark. So yeah, I don't know what will happen, but if it was me, I would plant a lot of grand fir.
Yes. It's noted. Okay, so let's go to story 2. Are you ready?
Yep.
Mm-hmm.
Cool.
Hit us.
Yep. Self-driving timber trucks succeeded in first forest trial. Okay.
Mm-hmm.
Yeah. So for the first time, self-driving timber trucks have been successfully tested in remote forest. The project led by FP Innovations and Kratos. And wow, go visit Kratos' page. That's a scary page.
It sounds scary.
Yeah.
It sounds like a Greek god, Kratos.
So let's see. Can I find the page?
When you say timber truck,
I'll get to it.
Okay.
Benjamin. I just want to find Kratos, like Kratos, or whatever it's called. So it's actually called Kratos Defense. Yeah. So I think this is a scary page, to be honest.
That's drones.
And military.
Yeah. But where is the company from?
Good question. It looks, American. Let's see. It's probably huge. They do stuff where it takes a huge company to do stuff like that. Yeah. It's huge drones and missile launchers and lots
timber
of
trucks.
Yeah, apparently. Okay, so coming back to the story, I was actually, what is Kratos? And then I went and found this page. I was like, it can't be that company, but it is. Okay, so FP Innovations and Kratos shows that automated trucking can work even in areas with poor GPS signals and tough terrain. So here are the facts, and it also sort of describes how it works. So the system uses platooning. Mm-hmm. A human-driven leader truck guides a driverless follower truck. I actually did that.
You know what to do.
I think was it second or third semester?
Fifth.
Are you sure? Yeah, sure. Yeah, you're correct. So it's tested in Quebec, Canada, under harsh conditions. So steep roads, dust, freezing temperatures, and no reliable GPS. So both trucks are equipped with advanced sensors, V2V, so vehicle-to-vehicle communication and automation. The leader truck adjusts speeds and maneuvers while the following truck mirrors, the movement of the leader truck. So only a safety rider is present in the driverless truck. Safety rider.
Yeah, that's someone who can push the brakes.
Yeah, so no active driver needed. So this method reduces resilience on complex AI alone and keeps a human decision maker in control.
Human in the loop.
Yeah. So why does it matter? So forestry trucking is dangerous and facing a major driver shortage, apparently. So in Canada, there's actually 25,000 truck driver vacancies and predictions of growing it up to 40,400 by 2030. So you could talk about a shortage.
If you need a good job.
Yeah. With you'll be mostly alone.
Yeah.
So automation could keep supply chains running, improve safety, and ease the labor shortage. Apparently, that in the article it actually says that that driver shortage has actually closed down mills and stuff like that because it's a huge problem.
I could imagine, yeah.
Yeah. So Kratos VP Maynard Factor says that this is a game-changing solution for keeping business running despite the driver shortage. So let's start with you this time, Rasmus.
Mm-hmm.
What makes this leader-follower approach more reliable than fully autonomous trucks?
Well, I can maybe start somewhere else because
Go ahead.
Given my background in control theory, this is nothing new. And actually, Volvo has done research in this for the past 50 years.
Yes,
they have actually run tests all across Sweden.
Yeah, with cars.
Yeah, but also with trucks.
Okay.
So the main idea is to platoon like 10 trucks.
Yeah.
And there's of course a lot of issues with that. One of a simple one, if one breaks, then everyone needs to brake, and you begin to get this harmonica effect.
Yeah.
Which is it's an oscillating effect in the control system, and you really don't want to have that. So that's why communication between them are so important.
Yeah.
But there will also be a small delay throughout this. So it is a vehicle to vehicle. The one vehicle communicate to the one behind it, and then behind it. Like we use the lights now.
Yeah.
As human beings. So the idea is not new. It has been researched a lot, and the idea is, I've guessed from Volvo, is still that this will be something that runs in on the freeway.
Huh?
And that's also what Tesla wants to do.
Mm-hmm.
Because if you can do this, then you can have a lot of trucks, and it's essentially an efficiency issue. You want to have a lot of
makes a lot of sense.
Yeah, and of course there's also a truck deficit. There's truck drivers. There's not a lot of them.
Yeah,
and it's an area where people. Yeah.
Would there have to be a safety driver in each?
No. When that's a trust issue. When you trust it enough.
I think as I recall it, when we did this project on fifth semester, I think so you have your Volvo, right? And you go to the freeway, the highway, and then you sort of locked into this, platoon. With, let's say, 5-10 cars, and it's just the system then takes over until you exit the highway again, right?
Yeah, and if anyone have ever seen the movie I, Robot, that's how the network works there. That's the idea.
Yeah.
You go into the flow with all the other cars, and then the system takes over, and then you leave the flow at some point.
Yeah.
And that's what the freeways, and that's also why is Tesla working so well on freeways and so on. That's because the environment is so structured.
Yeah.
And then maybe coming back to what about this? So having a human in the loop always makes it a bit easier, because you have some high intelligent being capable of making decisions which you wouldn't have
with a lot of sensors.
And
if he's not sleeping.
Yeah, that's the thing. So
on Netflix.
So and here you can argue that the environment is not so structured, so it probably is a bit harder. On the other hand, given that the environment is a bit harsh, you will probably go very slowly.
Yep.
And you won't have a lot of safety risks in the same sense if you have these platooning on the freeway.
Yeah.
So I would actually argue that this is a bit easier.
Yeah.
Because you can actually maybe accept some more of this harmonica effect. You can, and if it's only one leader driver and one, then it's really easy. That's not. I'm doing the finger thing here.
Yeah.
And so on. So it probably makes a lot of sense, but I don't think it's that.
I will actually also argue that I think it's simpler, the environment, because it's structure-wise, it's much more easy to distinguish, where's the road, where's the trees. But again, also, I know at least both of us, Benjamin, have liked some funny videos on LinkedIn with lorry drivers that it's really amazing how they can maneuver these trucks down, really steep roads with narrow bends and everything.
Yeah.
Of course, that's that makes it really complex.
I would say how would they load the truck if there's no driver?
Yeah, there's one in the first, so he'll probably
go back and forth.
Yeah, he'll probably just shift the lorry.
I think you should see it as you just have a really large truck.
Yeah. Good point.
Yeah. And the thing is that you say the issue with you don't have a good GPS signal, don't have a reliable one. The thing is now that's not that important anymore, because you have the first truck driven by a human being. That's now the GPS.
Yep.
So you can kind of use that, of course, combined with GPS and so on.
Yeah.
And then some local sensors, communication and local sensors, making it, obstacle avoidance and so on.
Yep.
It's not saying that this is easy, but I agree a bit with the environment actually being a bit easier, because you don't have a lot of what the thing is in if you drive around freeways or in the city, you have a lot of disturbances from a lot of people.
Yes,
and
a lot of moving parts.
Yeah, and that you kind of don't have that there.
Yeah.
So the safety should be easier.
Yep.
So yeah, it's probably. I'm not as blown away as the VP from Kratos, but
he's been on a marketing course.
Don't send a drone after me,
No. Yeah,
I don't understand.
Girlfriends.
The if you need a safety driver, why not just have a driver then?
That's probably legislations now. That's just so that you you don't. If there's just a safety driver, you probably don't need the same education and so on. So at some point in time where this system is deemed safe enough, then he also goes away.
Yeah.
Okay.
But that's you can.
And maybe you could even, let's say you have like additional controls in the first truck.
You could have like kill switch or something.
Yeah, he could just kill it, right?
Yeah.
Yeah.
But that requires.
I'll send the check, Kratos, for that advice.
Yeah.
It's free. No, it's not free. Okay, so Benjamin, how big of a fan are you of self-driving trucks in general in forestry? Do you now, of course, Rasmus and I, coming from a technology background, that's something that's always
that's been a wet dream.
Yeah,
always.
You're from you have another background within forestry. Do you see things moving around by themselves? Is that a scary thought or?
Yes. I mean, in Denmark, we're quite small.
Yeah, and we don't have remote areas in Denmark.
Not really, no.
Not in this regard.
And the forests does not have good roads. So
you don't think so?
No.
Do you think remote forests in Canada has better roads?
I mean, I almost think they do, but
okay.
No. And we have a lot of small forests in Denmark where it doesn't really make sense to
to have roads.
Well, they have roads, but to get a truck in the forest, you need a good road.
Yeah, exactly. That was what I meant.
Yeah. And a small forest doesn't make that much money, so to maintain a good road doesn't really make sense.
No.
And I know that's a big problem in Denmark, but we are also still talking about a lead, truck driver.
Yeah.
And I mean, I've been to Canada and I've seen the landscape and I've seen the videos of the truck drivers, and I have a hard time believing, and even if the lead driver makes a crazy move down a small mountain, that it will just replicate every movement there.
So it will also drive over the cliff.
Yeah, I mean, yeah, but yeah, I don't know much about the technology. Maybe it's very good technology. I don't know.
Yeah. Do you think it's very good technology, Rasmus?
I don't know for this specific case, but I just know that the research in it has been long going, and that this is essentially back to the whole self-driving cars thing.
Yeah.
And we all really like that idea, and we all like this platooning idea, because one of the things that also gives us so many issues with traffic is people's driving skills. It's not that there's not room.
Yeah.
It's that people drive horribly.
Yeah.
And if you can get that away and have them all platoon nicely, you can push much more through.
Yeah. You wouldn't have queues.
Yeah. Yeah, exactly. And that's of course some of the things that would be nice to solve for everyone. And this is kind of in that space.
Yeah.
So,
but if you look at this system in terms of sensors, computers, there's nothing new in this.
No,
right?
no, and that's the thing. It's not a new thing to think about this.
Yeah.
The thing, the new thing probably
you can be calm, Benjamin.
I mean, I can definitely see it on the highway making sense, but in the small roads in the forest, so much.
Yeah, and that's the thing. This will revolutionize. This will, because there's such a labor shortage. This will. If you really want to revolutionize this, then you solve the traffic issues.
Yeah.
That's the where you really want to solve something, because you are wasting so much time, so much energy, and something. So.
Yeah. Who do you think will come first?
For the self-driving cars?
Yeah, will we see it on the highway or in the forest?
Oh yeah, on the highway is already there.
Yeah,
essentially, you could the Tesla can do it.
Yeah,
and also other cars now.
Yeah.
So that's essentially there.
Yeah, but you still need a human.
Yeah, that's kind of the safety driver, right?
Yeah.
But in this case, he's also he knows how to drive, but that's what he's there for.
Yeah.
And that's also my point will be that you cannot create full self-driving unless you change the infrastructure. As long as we have this infrastructure,
and the law.
Yeah, and you have a lot of people that can, irrational decisions into that system, it's going to be impossible to solve.
Yeah.
Just let's say you drive around in a city. Who's going to stop that some person, runs right out in front of you? You can't.
Nope.
And if the car hits that person, then, all the self-driving, Uber stopped the entire self-driving car project because they ran someone down.
Yeah, but that's the funny thing, because if there were a human behind the wheel, he will also run down the person, right?
But that's not, and that's the thing, that's the technology trustworthiness.
You can't make it fly.
Yeah.
Maybe that's what you need to have.
Yeah, that just creates other issues when they go down. That's actually a whole argument for the Boring Company, is that it's just never going to be safe enough for these things. And then going underground is much more.
Yeah. I actually saw an interview once with where Elon, he said, I mean, what do you want the most? Do you want the stuff on top of you or beneath you?
Yeah, exactly. It makes kind of sense. You don't want that. Those, let's say, there's a million of human-sized drones.
Yeah.
Someone jamming every one of them is just falling down. But again, when we started with the airplane, the commercial air, you had more issues. But now there are very few issues. It's one of the safest transportation methods.
Yeah, exactly. Benjamin, do you think shortages of labor is that a huge thing in forestry?
Yes,
of course we hear a lot about those that actually maneuvers the machines in the forest, but is there a shortage?
Yeah, even in Denmark there is in such a small and especially good people. You want good people to work, but also the good people need to teach people they need to start somewhere to become good, obviously. And since the machines have taken over, back in the day, the men with the chainsaws, were on the ground doing all the work. Now it's machines, and we still need men on the ground for certain tasks, and there's not a lot left because first of all, they don't last that long because it's
dangerous
tough, and it's tough.
Yeah.
So we need people.
Yeah.
Okay, that's going to be a very hard issue to solve generally.
Yeah, I was actually thinking about last weekend, or was it the weekend before? I was talking to my dad about agriculture and automation in agriculture. I mean, that's
probably driven by it.
Yeah, it's more or less autonomous everything.
Yeah, and that's
in the field.
Yeah, and that's probably also driven by a shortage and so on.
Yeah, and productivity.
Yeah.
But again, the jump from these plain fields to the forest is just wow.
Yeah, and if you have these specialized tasks where you only need to go in and remove some small stuff or something like that, then pulling out of a big machine is also not. But it's a good question. Is there a market for replacing, those smaller tasks, like a small robot that could do something?
Yeah.
So
it's not easy.
Well, one way of making it easy is just going the whole fiber, and we just plant one trees in all lines, and we structure the environment so that it is very easy to take care of.
Yeah,
we would probably need bigger machines then. Actually, if the big grand firs, giant.
Yeah, okay.
Yeah, but
then we will just blow them because we just need the fibers.
Blow them?
Yeah, dynamite or something. We just need the fibers.
Yeah,
just evaporate them.
And a lot of the countries that don't use wood chips, they plant a lot less trees. And in France, for example, I was there. I saw a Douglas fir, I think 1,000 per hectare planted, and in Denmark they maybe plant 3.5 or something like that.
Yeah.
So, yeah.
And that's because they don't use the wood chip. So there's actually a market for the wood chip there, I can see.
Probably also other things, but the concern is that they become very low quality, not a lot of nuts, a lot of but they don't in the one I saw in France was not that bad.
What does they use grand fir for in France?
That was Douglas.
Douglas, sorry.
I mean everything.
Okay.
Construction and
and so it's fine. They only have like 1,000 plants per hectare.
I mean, in that specific spot I saw, yes.
Yeah.
It looked very good. A very good.
What's the cost of establishing 1 hectare where you only plant 1,000 trees compared to 3,500 trees? Is there a big difference, or
yes.
It's more or less the same?
It's a big difference.
Like big, significant?
Yes.
Okay.
3.5 times.
Yeah. I mean, both the plant costs something, and to get it planted costs something.
Yeah.
So if you remove 2,000 of those, yeah, it's huge.
Okay.
Huge difference.
Do you know why they don't use wood chips in France?
They don't have the industry like we do, the heat plants, and
You wonder why?
it's
Nuclear.
That would be my guess.
probably yeah.
But can you see that there's something funny here? Because for the environment, I'm not a fan of nuclear or anything. I don't know enough about it to actually have a educated opinion on it. But we are shutting them down in Europe.
Yep.
Which means that we'll probably need more wood chip to kind of compensate.
Yeah, solar.
Yeah, solar. Yeah, but yeah.
Yeah, it's funny with nuclear.
Yeah, I don't know where we are in innovation on that. I knew that Bill Gates had a lot of things going on with these micro nuclear plants. They were starting testing in Russia before it's mentioned in his book, before the first Donald Trump period where everything was shut down.
Yeah. There's also the Netflix documentary of Gates.
Yeah.
There's a lot of talk about that.
Yeah, that situation.
Yeah. I think it seems like nuclear is getting more and more popular again.
Yeah. As far as I understand, one of the issues with nuclear is that it is actually too expensive. Yeah. It's not just that it's dangerous, it's also it's pretty expensive to build these plants.
Yeah, and people would argue that it's not dangerous anymore, right?
Yeah, and that's until something happens, like the Fukushima. It wasn't dangerous, then something happens and it becomes dangerous.
Yeah. But I think that's also a very, very old plant, right?
Probably.
I think that's Bill Gates' whole thing, that new plants, you don't have that risks. But yeah.
It sounds like the Titanic story, this ship can never, it can't sink until it sinks.
Yeah, exactly. Okay, so let's wrap it up. Hot takes on driverless timber trucks.
I also thought about...
I think we'll see them everywhere. That's my hot take.
Okay. I would like to see them on the highway. I was imagining, driving on not a highway, but quite a busy road, and an 80 kilometer an hour road. And I see a platoon of 10 trucks I have to overtake because they're driving a lot slower. That would annoy me.
So if you had like a very, 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 very large forest, really remote, you have like these big, let's say, highways throughout the forest, would it make sense to have like, or maybe you would have a train at that point in time, but would it make sense to have like trains of trucks, where you have like 10 platooning, and you'll have someone, satellite truck driver that actually brings the lorry down, go and pick a new one, and it will be picked up by these driverless platooning.
The next thing, the one who actually controls the leader vehicle, is she requested to be in that vehicle? In the future, you could just sit as a remote pilot.
Yeah.
You have you. That's how you operate drones. So it's not like you can't do it.
Yeah, you're right.
In areas where you have poor connection.
Yeah. What do you think about that?
I mean, I can definitely see it, but yeah, once again, in Denmark, there's rarely a forest.
Don't talk. It's not for Denmark.
But I can see it, like you said, you almost have a transportation. What's it called? When you at Ford started the whole how you industrialized the way of building cars.
Yeah.
It's called, what is it called?
Like a main line.
Yeah. You just
production
have that.
line.
Yeah, you just have a production line now.
Yeah.
It just transports everything down all the time.
Yeah.
You're not having anything like this now. It's just all the time running.
Yeah.
Because he saws out all the carbon from the forest.
Yeah.
Automation is coming.
Yeah.
It has to.
That's your hot take.
Yeah.
Good. Let's wrap it up. And this was actually episode 30.
Booyah.
Yep. See you
30
see you in 31. Take care.
Bye.
Okay.
Bye.